We are going to look at multiplying complex numbers. The nice thing about multiplying complex numbers is that it should feel very familiar, because when we multiply complex numbers, it's the same as multiplying polynomials. We will use the distributive property, or those of you that are familiar with the FOIL method, we will see the FOIL method in action as well. The one new thing you have to remember, though, is that anytime you see the term I squared in your answer, you have to replace it with -1 before you get your final simplified result. Let's take a look at part A. We want to multiply the term 4i to the binomial 3 minus 5i. So what we're going to do is we're just going to distribute 4i to each term. So 4i will be multiplied by 3, then we have a subtraction sign, and then the 4i will also be multiplied by 5i. When I multiply 4i times 3, I get 12i, minus, now I'm going to multiply 4i times 5i. So 4 times 5 gives me 20, but when I multiply I times I see I squared. So remember, whenever you see the term I squared, you want to replace it with -1. So this becomes 12i minus 20 times -1. So I've replaced I squared with the real number -1. So I have one more step until I'm completely simplified. So this becomes 12i plus 20 because of the two negative signs. And then I do want to write it in the form a plus bi, where 20 is the real number part and the 12i is the imaginary number part. So my final result is 20 plus 12i. Let's look at part B. Now we're multiplying the binomial 7 minus 3i times the binomial -2 minus 5i. This is where we will be using the FOIL method, where we will be distributing 7 minus 3i into the binomial -2 minus 5i. So first, I'm going to multiply 7 times -2. Then on the outside, I'm going to multiply 7 times -5i. On the inside, I'm going to multiply -3i times -2. And for my last two, I'm going to multiply -3i times -5i. So those are my four terms. First, outside, inside, last. So my first two terms was -7 times -2, which gives me -14. My outside terms, 7 times -5i, becomes minus 35i. My inside terms become plus 6i. And my last two terms also become plus, so -3 times -5 becomes plus 15, but when I multiply I times I result with I squared. So here are my four terms. So I'm going to combine like terms in the middle, but then I also need to remember that since I see the I squared, I'm going to replace it with -1. Because remember, I squared is equal to the real number -1. So let's take a look. I have the -14 as my first term. In the middle, I'm going to combine -35i plus 6i, just like if I were combining like terms with a variable, except now I have the imaginary unit I. So that becomes -29i. And then this last term becomes minus 15, because I'm multiplying the positive 15 times the -1 for the I squared. Then I can combine my constants. -14 and -15, when I add those together, becomes -29, and then I have the minus 29i for my final answer. Let's take a look at part C. The binomial 2 minus 3i is being squared. So remember, it's a good habit to write it twice, and then use your pattern for squaring a binomial. So the pattern in this case, since it's a difference, is going to be a squared minus 2ab plus b squared. So let's identify our value for a and identify our value for b. But first I'm going to write the skeleton, and then I'm going to insert my values for a and my values for b. So my value for a is 2. So everywhere I see a, I'm going to replace it with a 2 in my skeleton method. And my value for b is 3i. So everywhere I see b in my skeleton method, I will replace it with 3i. So I get a squared, which is 2 squared, minus 2ab becomes minus 2 times 2 times 3i. And then at the end, for the plus b squared, it's plus the term 3i squared. 4 minus, now I'm going to multiply 2 times 2 times 3 for my middle term. So that's going to become minus 12i. And then at the end, that gives me 9i squared. And I'm going to replace that I squared with negative 1. So I have 4 minus 12i plus 9 times negative 1, which becomes 4 minus 12i minus 9, and then combine those constants for negative 5 minus 12i. And there's my final result. All right, one more in part D. Hopefully you recognize the pattern of conjugates in part D. 5 plus 4i times its conjugate, which is 5 minus 4i. So when you multiply conjugates in general, the rule is a plus b times a minus b results in the difference of squares, which is a squared minus b squared. So let's identify our a value and our b value. Our a value in this case will be 5, and our term for b will be 4i. So my result is a squared minus b squared. So in the term a, I'm going to replace with 5. And then for b, I'm going to replace with 4i. So 5 squared gives me 25 minus, now when I do 4i squared, 4 times 4 becomes 16, and I times I becomes I squared. Remember one more step, we have to replace that I squared with negative 1 to get our real number answer. So this becomes 25 minus 16 times negative 1. And then some order of operations, we get 25 plus 16. And notice now our final answer is just the real number 41, because we can combine the real number 25 plus the real number 16. There is no I in our answer anymore. It's just the real number 41. I hope you enjoyed this video, and now you are a master at multiplying complex numbers.